Hey, Emin.
Hey, Jeff.
Good to see you. Welcome to our course, everybody, on advanced exploitation techniques. Our goal is to help you understand what advanced exploitation techniques are and how you can use them in your penetration testing. So we're here to help, right?
Absolutely.
It's what we're all about. Now, we will start by understanding what the word exploit means in the terms of computer security and in the community. Then we're going to learn about how to use metasploit to exploit vulnerability.
Really?
Really?
Exploit is a common term in computer security communities to refer to a piece of software that takes advantage of a bug or a glitch in your system. Now, it could lead to a privilege escalation or denial of service on a computer system. Exploits are classified by different categories depending on the type of vulnerability they attack. All right? Some examples are buffer overflows, format string attacks, race conditioned, and cross-site scripting.
And many of these exploits are designed to provide root-level access to a computer system. But here's a point I want to make.
Right.
It is also possible to use several exploits. First, to gain low-level access, then, after that, to escalate privileges repeatedly until one reaches root. Once a vulnerability is published, you will then get a newer version of the software with the fix, or developers may then release a patch, which often happens.
Absolutely.
Now, black hat hackers do not publish their exploits, but either keep them private to themselves or give them to other malicious hackers. Such exploits are referred to as zero-day exploits, and to obtain access to such exploits is really the primary desire of unskilled malicious attackers, so-called script kiddies. They sound innocent, but they're really not.
They aren't. It's very common. And we want to briefly introduce exploit development. So let's look at the body or structure of an exploit.
Okay.
And we have exploit options, network connection handler, payload, shellcode, setup and encoding, request builder, and handler routine. Now, here's what are shellcodes? Well, they're payloads, which is to be executed after exploitation. In most cases, the path of the execution is redirected so that the injection payload is then executed. So the return address is made to point to this shell code, and it comprises of assembly instructions encoded as a binary string, which performs operations like spawning a shell. A good piece of shell code must be a trade-off between size and complexity. Now, there are a lot of verifications to be made during payload encoding, like keeping a check on restricted characters. Payloads have been customized to be very short and to require less space. They can execute many complex operations, from opening a listing socket to loading a compiler on the remote computer.
Right, injection vector is the pointer or the offset where the shellcode is placed in a process and where the return address is then modified to point toward, right, or to. Request builder is the code which triggers the exploit. For string functions, scripting languages are generally preferred. Handler routine generally consumes the majority of the code. This is a handler for the shell code doing operations like linking to a bind shell or connecting to a console to a socket.
Yeah. So let's go ahead and get started here. Now, we're going to look at the user options handler first. It's basically a user-level front end providing the user with various control options like remote target selection, offset selection, verbosity debugging, and other options. This forms the majority of the exploit code, and it makes the code quite bulky.
Right.
Now, finally, let's go ahead and look at network connection handler. Now, this is comprised of the various routines which handle network connections like name resolution, socket establishment, error handling, etc.
Okay, good.